Launched in 2015 by Vitalik Buterin, Ethereum's native token, Ether or Ethereum, is the second most popular cryptocurrency by market capitalization after Bitcoin, with a total market cap of over 163 billion. Now, recently transitioning from a proof of work to a proof of stake consensus mechanism, today Ethereum has appreciated in value over 46,000% since launch. Now, we're joined today by Anthony Sassano, independent Ethereum educator, investor, and advisor. There's no one better to talk to about what's going on in the Ethereum ecosystem. So we're so glad to have you back on the podcast. So first questions first, how did you earn your first pound, dollar, buck? Tell us a little bit about how you learned about money.
Yeah. So thanks for having me on again. Excited to have this chat with you today. So I'm in Australia, so I earn Australian dollars when I work. Well, I mean, it's varied these days because we're in crypto, but before then, if we're talking about my first buck, it definitely was in Australian dollars, right? And it was as a teenager, odd jobs here and there, and do things for my parents and things like that, right? And then you get a job, a part-time job, and you earn money that way. And I never really questioned money back then. I mean, I'm 30 years old now, so it was before Bitcoin was around. Bitcoin came out, and obviously, I think I was still a teenager, 17, 18 years old. But even then, I wasn't into Bitcoin at that point. I think when I first started questioning money or like looking deeper into how money functioned, how it all worked, was when I first got into Bitcoin in 2013. And I really got into Bitcoin in 2013. I became orange pilled basically instantly. I bought into all of the things that people were talking about with regards to how money functioned, how Bitcoin is a better money, better than state issued money, better than fiat, all these sorts of stuff. And I really took to heart a lot of those arguments because it was really the first time that I had questioned those kind of concepts and topics. And I started looking at the world around me and being like, wow, this actually makes a lot of sense, and this is how it all works under the hood, but no one really pays attention to it. So that was kind of my first foray. Funny because it was my first time in crypto, I kind of lost interest when the market went down, as a lot of people do usually in their first time. I was still interested in the concepts and everything about it, but because I was very young, obviously the making money from it was very interesting to me because I didn't have much money back then. So it was kind of top of mind for me. So what ended up happening was that I kind of took a break from the ecosystem in 2014 till 2017 when I discovered Ethereum, and then it kind of was much more to me. It meant much more to me than Bitcoin did at the time because I saw Ethereum and I'm like, okay, well, Ethereum has its native currency, ETH. It is a money. It is a store of value. I know that's debated, but people are using it as that. So to me, it's that. But then you can build all of these applications on Ethereum. And this was actually talked about in 2013 with regards to Bitcoin. Everyone was talking about these applications you could build. And there was all these really cool ideas that had been talked about for years at that point still. And then what ended up happening was that Bitcoin, for better or worse, just didn't allow for that to be built on its base layer. Ethereum came along, and then you had all these things being built. So the rest is history from there. But that is what really attracted me to Ethereum and made me make Ethereum my main kind of thing within crypto. Was it had the money aspect, but it also had this aspect of building things on top of it, which could enhance the money, so to speak.
Cool. So from basically doing odd jobs to learning about digital currency when Bitcoin was launched, to then learning about an extendable capability for much more than just sort of payments on the internet. And that was sort of the, I'd say, genesis of Ethereum's original sort of story was like, we can do a lot more with this. We want to start to deliver against that. So Bitcoin sort of started off as an experiment to build peer-to-peer electronic cash for the internet. And there's been a lot of effort to kind of crystallize that. But then there's also people that argue it sort of landed more in like a store of value digital gold kind of use case. Whereas Ethereum has been constantly efforting, doing much more on the extension of what a giant computer system on the internet could really deliver on. So let's talk a little bit about that. Who created Ethereum? What's sort of the origin story of it? With Bitcoin, there's sort of this, we all know that Satoshi Nakamoto was the pseudonym of a developer or a group of people that basically launched the network, but then really stayed out of the limelight and allowed the work to carry on as an open source project. Ethereum's a little bit different. So talk to us a bit about some of the founding personalities and maybe a little bit about the story and the origin of the Ethereum protocol.
Yeah, so as you mentioned, Ethereum is definitely different to Bitcoin in its founding. It doesn't have an anonymous founding team. That's one of the major differences, right? Like everyone knows who Vitalik Buterin is, and the rest of the founding team. You know, most people know that the most popular ones, such as Joe Lubin and a few others there. So there were actually a lot of founders of Ethereum, so to speak. But the thing about Ethereum is it had a very, I would say, colored start to life. I think Vitalik was extremely young at the time, early 20s, I believe, or just turning 20. He obviously didn't have any business experience, didn't have a lot of real world experience because of his age, but he managed to get all these people together to work on this thing called Ethereum, right? They did the ICO in 2014 to raise some money, and they spent the next year building that out, and it launched in mid 2015. But I think the reason why it's so colorful is that a lot of the founding members just aren't working on Ethereum anymore, or I haven't worked in Ethereum for a very long time. So the people who still work in Ethereum are the founding members of Vitalik and Joe Lubin. Joe Lubin, obviously, with the Consensus, the company he founded, but other people like Gavin Wood, for example, actually worked on Ethereum till around 2017, and then started working on Polkadot, which is essentially a competing chain, I guess, to Ethereum. So, and then there's all these other personalities as well. I mean, it's debated whether Charles Hoskinson is an actual founder or not, but you know he was around back then. He's working on Cardano. There's a bunch of others people out there who are not even in crypto anymore. So it's definitely very colored. And the founding, I guess, not just the founders, but the founding team, some of them are still working within Ethereum. Some of them moved on to other things. Some of them aren't in crypto anymore. So because it's been so long now, you expect that to happen. But it's fun when you look at the people that are around today. Obviously, Vitalik is still working within Ethereum. He is still a very big part of the project, and it doesn't seem like he's going to go anywhere, right? It's his life's work. But then there's other people. One of them that people may know, Peter from the Geth team. So Geth is the main Ethereum client that people run, or one of the most popular Ethereum clients that people run. And Peter is the lead architect of that client, and he's been around since day one. And there's a bunch of other people like that, but that may be someone that people are familiar with. So, but I always kind of say to people, it's actually amazing that Ethereum has made it as far as it has, considering that it was the first smart contract blockchain to, I guess, get as big as it did. There was other ones out there, but they were kind of irrelevant. So I would say it's the first one that actually gained relevancy. It's had lots of different things happen in its past, such as the DAO hack, which people may have heard of, right? The ICO mania, which brought a lot of attention to Ethereum, DeFi, NFTs, all this stuff gets born on Ethereum and then obviously exported to the rest of the crypto ecosystem. But that really has, I guess, attracted a very varied set of people as opposed to something like Bitcoin, which is that singular use case. You mentioned it started off as a money, it's kind of gravitated towards more of a store of value, and it definitely optimizes for a certain persona, whereas Ethereum is a lot more expressive. There's very different personalities in it, and I think that started with the founding team and has continued up until today. I mean, as I said, like I got into Bitcoin, I really bought into a lot of the things that they were excited about, but over the years, I actually changed my mind on some things. I don't think just a store of value, a digital gold is enough. I think that we obviously need to take this technology much further. That's why what Ethereum is doing. That's why I'm so excited about Ethereum. But there's nothing wrong with people just wanting that singular use case. And I totally understand the value of Bitcoin to those people. But I think you can see those divergence in cultures. And especially if you spend any time on Twitter, on Reddit, there's kind of like these tribal culture wars going on all the time. And I really do think that's just because there's just a massive difference of opinion between these sets of people about what this technology should actually be.
Yeah, it's kind of funny that a lot of them did start off, sort of as maybe Bitcoin enthusiasts, and then sort of expanded on some of those original principles that were kind of common, which were an interest in decentralization, an interest in censorship resistance, and an interest in building a new way for people to share precious information over the internet. And at this point, you start to get some of the dogma about, well, how do you go about doing that? And
Mm-hmm.
I think you saw the personalities basically head off in different directions. Many of them pioneers in Bitcoin and then founding fathers of and sisters of Ethereum, going out and then approaching this colossal problem set in very different ways. So let's talk a little bit about Ethereum in your own words, though. What is Ethereum and what does it do? If you were to try and give it a layman's answer.
Yeah, so this question's always fun because I think Ethereum is different things to different people. It always has been. Some people believe it is a world computer. Some people believe it is a settlement layer. Some people believe that it hasn't actually achieved any of its goals, and doesn't actually do anything, right? I mean, there's always those sorts of people. But to me, what Ethereum is today and what I expect it to keep evolving into over time is this kind of globally, credibly neutral infrastructure for basically anything to be built upon. But that doesn't mean that Ethereum, as the base layer, the Ethereum network itself, is going to be hosting all of that on that kind of base layer. And that's why people may have heard of scaling solutions such as layer twos and roll ups and things like that. So Ethereum really is just this layer that settles all of that activity, so to speak. So it's global. Obviously, it's decentralized. It's always online, and anyone can use it if you pay the right fee. Obviously, fees on Ethereum are not cheap, but if you pay the fee, you can use it. You get access to the Ethereum network. So to me, it's just that global, credibly neutral settlement layer. Now, that doesn't mean you can't do world computer stuff at the higher layers. You could do it at layer 2 or layer 3. You could have more scalability at layer 2 and layer 3. And the beautiful thing about that is that you actually get the benefit of Ethereum's base layer or layer 1 through inheriting its security. Now, this goes into more technical kind of aspects of Ethereum, but this is what I think people maybe misunderstand about Ethereum is that they say, oh, Ethereum's failed at being a world computer, or it's failed at scaling, it's failed at this. And I think what people need to realize is that Ethereum is taking what's called a modular approach to things, where you have different layers of the stack handling different things. So there's this concept within crypto called modular and monolithic blockchains. A modular blockchain, such as Ethereum, has layer 1, layer 2, layer 3, multiple layers, right? Whereas a monolithic blockchain, such as maybe something like a Solana, wants to try and do everything on layer 1. And there's arguments for and against each of those solutions, but I think people get the wrong idea because Ethereum definitely probably did start out as a monolithic chain, and it has been up until recently, where it tried to do a lot at layer 1, and then as time went on, we realized, okay, well, doing everything at layer 1's not workable, it's not economical, it's not practical. We need to scale via layers. There's been this concept of sharding that's been talked about for a long time. That's evolved considerably from the original ideas around that. So there's just these different schools of thought. Just like how there's different schools of thought between Bitcoin and Ethereum, there's different schools of thought between how Ethereum is going to scale, what Ethereum is to the world, as opposed to one of these other smart contract chains. Because there's plenty of them, right? And they always talk about, hey, we're cheaper than Ethereum. We're faster than Ethereum. We have a better security than Ethereum. And those claims can be debated endlessly, right? Depending on who you talk to. But I think the crux of it is that Ethereum really is just trying to be that global, credibly neutral settlement infrastructure that anyone can build upon, but it's not going to have all the use cases hosted on that layer 1. Those use cases may be hosted at higher layers, so to speak.
And I think said another way, like Ethereum has been in some ways so successful that there have been new shots on goal by other founding teams trying to extend or create a different sort of base layer to attack some of these problem sets. But so in summary, one way to summarize what is Ethereum? It's a credibly neutral technical infrastructure to build applications on the internet. Now, I would like to talk about a couple of those. Can you maybe pick like 1, 2, or 3 sort of widely adopted applications that are running on the Ethereum protocol today to talk a little bit about how that's quite different than what Bitcoin does? I think Bitcoin, we know, allows people to send a denomination of value over the internet. It settles in roughly 10 minutes. There you pay a small fee that goes to the network for the utility of that. And that's kind of like the main use case today. I would say payments over the internet, but not necessarily at wide scale itself. They're working on that as well. But over on the Ethereum protocol, they are actually quite a different set of problem sets that are being solved for, and some applications have been built with real world utility in large communities. So, what are a few examples of those applications you think can sort of teach our audience about what is being built on this technical settlement layer for the internet?
Yeah, yeah. So just on the Bitcoin point there. So the reason why Bitcoin, I'll name the applications, but the reason why Bitcoin can't host these applications natively on its base layer is because it just simply does not have the functionality to do so. Just like a pocket calculator doesn't have the functionality to play a video game, or maybe it does. Maybe it can play Doom, right? You've seen those out there, but you get the analogy. But Bitcoin does not have smart contract functionality. It does not have an inbuilt virtual machine. It cannot process and execute this arbitrary logic that Ethereum can. And because Ethereum can do that, we get all sorts of applications. Now, the most popular one, I would argue, is Uniswap, which is something called an AMM, or an automated market maker, and it's an exchange. So basically, what you can do is, and I'm sure a lot of people have done this already, you can go to the Uniswap website. You can select, hey, I want to trade some, maybe a stable coin such as USDC for ETH, and you input how much ETH you want or how much USDC you want to use to buy ETH with, and you click swap. All right. And that all happens on chain, on the actual Ethereum blockchain for you. And Ethereum blocks are every 12 seconds. So if you've paid the right fee, you'll get included in a block. So, and that'll all get settled, and you'll end up with the ETH that you wanted to purchase there. So that is obviously the most popular application, because trading within crypto, I think, is still the most popular use case of this technology right now. Speculation is obviously what drives a lot of this industry as it exists today. So Uniswap, most obvious one. There's other ones that are non-financial in nature. So Uniswap is what I would consider obviously a DeFi project or decentralized finance project. Then there is something called ENS, which stands for the Ethereum Name Service. Now, what this application allows you to do is register your own name and tie it to your Ethereum address. So just like you can register a domain name, such as anthony.com, for example, and tie it to an IP address, you can register, I've got sassel.eth, which is tied to an Ethereum address, those 0x blah, 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 that you see when you're using Ethereum. And then people can use that address instead of using that complex kind of long string of characters there. And that is obviously very popular because it's just much easier. Like, imagine if we had to use the internet with IP addresses, the internet wouldn't get mass adoption. It wouldn't have been mass adopted at all. So that's another very popular application. And there's one other one, again, non-financial in nature, called Gitcoin, which is basically a public goods funding platform or a donation platform, whichever way you want to go with that. But basically, you can make donations to various projects. You can post bounties to get work done, all this sorts of stuff. And you can do it fully on chain in crypto. And they even support the layer 2 networks as well. So there's that. But I should mention as well, like, I know I've already given 3, but there's also the NFT side of things, which I think people are very familiar with. So OpenSea, obviously absolutely massive application. The thing with OpenSea is that it's really just like a front-end marketplace. So the OpenSea website is just centralized. It doesn't actually live on the Ethereum blockchain, but all the transactions that you do through OpenSea and trading and everything, that gets settled on chain. So you can have these kind of hybrid things where the front end obviously is centralized, it's controlled by some party, but it talks to Ethereum as a back end, just like a normal website talks to a database as a back end. And Ethereum basically becomes that infrastructure that I was talking about before.
Cool. So these applications are basically supporting real world use cases for everything from the exchange of value to creating essentially a almost like a new website or name for yourself on the internet, which will, I think, play nicely long term into your digital identity. You'll be able to share that with people, and they'll be able to trade in against that. Gitcoin's a cool project for getting projects funded. And then obviously NFTs have been an incredible story kind of coming out of 2021. And I would say this year we've seen sort of a bit of the froth taken out. But the use cases for NFTs, I think, are extendable, and we'll see those basically get applied across all kinds of industries over the next 10 years. I'd probably like to pick your brain a little bit about that. But there was a really important event that happened just a few weeks ago. One of the largest coordinations of a computer upgrade in the history of the internet was the Merge. And so this was a long time coming. It spent some time getting delayed. It was a very complicated upgrade to a live system. Talk to us a little bit about what was going on there. Made the press. The Economist wrote a front page news article about this. And why is this so important and significant to the Ethereum community?
Yes, I think I've often found it hard to just kind of describe how massive this achievement was, because for everyone in the world, basically, especially all the users of Ethereum, nothing changed, right? We did the merge, the chain kept processing transactions as normal, and the users didn't really feel any different, right? You could just do your transactions as normally. But that does not explain what happened and the major achievement that was done, as you said, a few weeks ago. So essentially, the TLDR of what the merge was basically moving Ethereum from a proof of work consensus mechanism to a proof of stake consensus mechanism. Now, they did this live on a financial network that, as you mentioned before, has a market cap of over $160 billion. It settles trillions of dollars of worth of value a year. And there is constantly people doing transactions on the network, every block, all the time, 24/7. Now, you can imagine what kind of testing needed to go into this thing to get it to the point where you could have certainty that nothing was going to break, right? Or have relative certainty. Obviously, you can never be 100% certain, but getting to that point where you can say, okay, well, we have 99.99% 100% certainty that we've, got dotted all our I's, crossed all our T's. This merge transition is actually going to go through. It's actually going to work, and it's going to all be smooth. And that's exactly what happened. To the surprise of actually a lot of people, we expected it to go smoothly, but it went really smoothly. Like, there is this concept of in proof of stake where you are a validator or a staker, and sometimes with these upgrades, some of these validators will fall off. So they'll go offline because they forgot to update their software, and then they'll obviously update and come back online. And with all the testing that we did, we saw that from time to time people would fall off because of such and such reason. But we did the merge, and I think only 2 or 3% of the network actually fell off, which was incredibly small compared to what we saw in the test nets. And everyone was like, wow, we actually did this like perfectly. Like, this is as well as it could have gone. So unless you know all the background that happened there, you probably don't understand how monumental of an achievement that is. But it was very big. And as I said, it happened and no one knew any different because that's what was supposed to happen. Like, no
Yeah.
users weren't supposed to feel any different about it. So as I said, I find it hard, like, unless you're in the Ethereum ecosystem, to describe to people like how important this achievement was. And I think that the second order effects that flow on from this is basically, investors, people, users, whoever looking at Ethereum and being like, wow, they just completed the biggest upgrade of any network in crypto ever, and it went so smoothly that users didn't even notice any difference. Like, this is a huge boost of confidence in Ethereum and a huge vote of confidence for the people building these upgrades for Ethereum. And I should note as well, there has never been a blockchain, especially nothing as big as Ethereum, that has changed its consensus mechanism live, right? From proof of work to proof of stake.
I don't think people really get how complicated that is. I had someone sort of provide an analogy the other day. It'd be almost like changing an F1's petrol engine while in race to an electric one without skipping a beat and not
Mm-hmm.
even stopping at the pit. And so
Yep.
the technical complexity in achieving this, the coordination, having a global launch, and all of the miners with only a 2% drop on that is pretty incredible. I'd argue it's one of the most coordinated like engineering accomplishments of the past 2 decades, and hopefully we'll see some of the longer term effects of that. Let's talk a little bit about this because I think proof of work has come under a fairly significant amount of criticism from everything from think tanks to environmental groups to even some regulators. And it's inspiring a conversation about alternatives. Ethereum has achieved a switch from a proof of work to a proof of stake system. Can you give a little definition around those two things and a little more, I would say, depth to what those two labels are and why this is a big deal for Ethereum?
Yeah, so I mean, at the heart of it, basically what the difference is between the two is that one uses some hardware and electricity to validate, secure the chain, and generate new coins. The other uses still software, still hardware, but instead of the miners using up all the electricity and having to kind of obviously use a lot of resources, we replace it with a stake. So with a deposit of the native token of the chain. So for ETH, a validator is 32 ETH. So if you want to be your own validator and run the software and just not rely on anyone else, you can deposit 32 ETH, run your validator, and you'll start earning rewards and securing the network and doing all that sorts of stuff. Just like in Bitcoin, for example, or a pre-merge Ethereum, you would spin up a miner using a mining machine, such as an ASIC or a GPU, and you would generate rewards. But to do that, you would have to obviously run it 24/7, run it at not at capacity, but like pretty near capacity, use a lot of electricity, and then because it scales up with the price, right? And as the price goes up, the hash rate follows that. So more and more miners come online, the electricity use goes up with that, and that's what proof of work has come under fire for. I don't have a strong opinion on the energy use. Like, for me, proof of stake was not about reducing Ethereum's energy use as the primary thing. For me, I just think that Ethereum's version of proof of stake is just more secure than its proof of work version. And there's a bunch of other reasons as well why I like it. But when it comes to the energy stuff, my general opinion on it is that the crux of the argument is anyone should be able to use as much energy as they want as long as they're paying for it, but it's what that energy is being used for. A lot of people outside of crypto obviously don't think that the energy use that Bitcoin is using is actually justified by the value that Bitcoin brings to the world. Whether that's true or not is obviously up for endless debate, but I think that is the crux of the argument, right? Like, because you can start moralizing about electricity usage until the
Right, but you're
cows
going to
come home.
complain about using a drying machine in Europe or because of high electricity costs, but you also need to heat your home, and you might want to make sure you don't head outside with wet hair. And so there's all kinds of I think equivalencies that
Mm-hmm.
don't really line up. to the value they add to the world. And it's sort of convenient for people to go, oh, well, that's not a good use of energy, but this is a good use of energy. But I think if you start policing that, you end up with some pretty adverse consequences too. So I completely agree. I want to dig into one thing real quick on this because it's super important for people to understand. So we learned in Bitcoin that there's 21 million coins. A few more get added to circulation every time a new block is discovered by the miners. So in this upgrade with Ethereum, if you deposit 32 ETH into a node, or you do that with a service that is also staking on the network, you start to earn rewards. So what changed in the reward schedule during the merge, and how are the economics of Ethereum sort of playing out going forward? So in the past, it was a bit inflationary. This has changed, or is in the process of sort of adjusting. Walk us through that, because I think one of the core arguments that got a lot of people excited about cryptocurrencies in general was sort of a predictable inflation schedule, a predictable set of economic supply dynamics that everyone could understand and agree to, because it was hard coded into the network. And this is in a world today where we're seeing unprecedented amounts of inflation across major markets in the world. The price of goods is increasing, and we are seeing very aggressive responses from everything from the Federal Reserve to the Bank of England to the ECB in trying to curtail this inflation. And I think this is one of the core arguments for cryptocurrencies in general. And the merge has really sort of changed, I would say, the economic game for Ethereum in a really fundamental way. So let's talk about the economic and inflation schedule of Ethereum, please.
Yeah, so the merge did substantially change Ethereum's economics. So did EIP 1559, which is that fee burning EIP that went live over a year ago now. But I'll try and be as concise as possible here, because this does get quite technical and it does get quite lengthy if I start going into the deepest parts of this. But essentially, I'll contrast it with Bitcoin, because Bitcoin has a very easy to understand monetary policy. That's why it's so popular, right? As you said, there is a maximum supply of 21 million that gets issued to miners every 4 years. The issuance halves from what it was previously, and that continues till the year 2140, where the last Bitcoin will be mined. Well, technically, the last Bitcoin will never be mined. It'll just keep halving, right? But it gets to a point where it doesn't really matter anymore. So that's Bitcoin in a nutshell, right? Whereas Ethereum has had an evolving monetary policy since Genesis. It had a certain percentage at Genesis, then there was an upgrade that reduced it, then there was another upgrade that reduced it. I think the first one reduced it from 5 ETH per block to 3 ETH per block, then 3 ETH per block to 2 ETH per block. And now with the merge, it's reduced that by about 85% at time of merge. So it's not a fixed thing per block anymore, though, because the way rewards on proof of stake work is you get rewards for proposing a block, but you also get rewards for what's called a testing to blocks. So it's very, very different to how it works in proof of work, where it's just like that fixed amount per block, right? But what this means is that every staker on the network earns the same yield, right? So if you have 32 ETH, put it into so I should say, so earns the same yield as protocol rewards. So there are different types of rewards. There are protocol rewards, and then there's obviously fee rewards, which are obviously different, and depending on what blocks you propose will depend on the fees that you get. But in terms of the actual block rewards, so to speak, or protocol rewards, everyone gets the same percentage. And that percentage will vary based on how much ETH is being staked. So more ETH that gets staked, the lower that yield will be for people. The less ETH is staked, the higher that yield will be. So right now, I believe it's 4.5% or something of protocol rewards. So every single staker gets the same. Doesn't matter if you have 10,000 ETH or 32 ETH, right? You get the same. Obviously, in the ETH reward denominated and dollar denominated, it'll be different. You get more rewards for staking more ETH, but the actual reward rate remains the same, which I think is really, really cool, because it means that you don't have to have this massive industrial mining farm just to be profitable on the network as someone who validates or mines or stakes on the network, so to speak. But how that plays into the economics is that it means that Ethereum does not have a supply cap, and this is by design. Ethereum has prioritized predictable perpetual inflation so that we can keep paying the stakers forever, right? And then we offset that inflation via the fee burn. So as I mentioned, there is this thing called EIP 1559, which was an upgrade that went into the network over a year ago that burns about 70 or 80% of the total fee revenue of the Ethereum network forever. Basically, every single transaction burns about 70 or 80% of that fee revenue. Now, once the fee revenue reaches a certain point, it actually starts to 100% offset the issuance of the year, so to speak. So essentially, what ends up happening is the issuance nets out to zero and then can go deflationary if the fee revenue is high enough, if the fee burn is high enough, I should say.
Right. Meaning
So
enough
that's
people are using the network that it's basically going to cause it to become slightly deflationary. And so the more demand it gets, the more valuable the network becomes.
Yes, exactly. And it means that Ethereum does not have to rely on fee revenue for its security, which is what that's a long-term security plan for Bitcoin. Because obviously, as you keep having halvenings, the supply gets the new block rewards, new issuance by block rewards gets lower and lower, and the network, if the price of Bitcoin doesn't go up, becomes less and less secure. And then if the fee revenue, which it hasn't traditionally been, replacing that block reward to make up for that lack in rewards now, you end up having a very real security risk, which is something that Bitcoin has come under fire for a lot over the last couple of years, especially. But this is why Ethereum does not have a supply cap, because we think as a community that it's better to have predictable, perpetual low inflation, right? That pays to the validators on the network to secure the network, and then use the fee revenue to offset that instead of relying on the fee revenue to make up for, the dwindling reward. So I think, as I said, like Ethereum's monetary policy is much more complex than Bitcoin's. There's a lot more going on, but I think that complexity, it's always a trade-off with complexity. That complexity gives us a better system, in my opinion, than what Bitcoin has. And I think that as long as the inflation is relatively low, and as long and it's basically, I mean, since the merge happened, fee revenue has actually been quite low because of the bear market. But the inflation rate of new ETH being issued, counting the burn, I believe right now is 0.15% or something per year. So that's like, it's not even consequential because you just have to have enough money, new money coming in to offset that anyway, like to buy ETH and take it off the market. And you can even offset it by looking at how many people are staking their ETH. So if I don't know how much it is in ETH terms, but let's say 500,000 ETH gets staked that year, 500,000 ETH gets issued. Well, that offsets it too. And then you have the fee burn that offsets it even more. So really, inflation is this kind of boogeyman word or bad word within crypto, but I don't think that should be the case. I think that as long as you have credibly low inflation that is offset by other means and is not changing all the time, we don't expect Ethereum's monetary policy to change from here, really. I mean, and if it does, it'd be because it was really important to change it. I think that's very, very important rather than sticking to something that was decided arbitrarily by the original creator of some hard cap when there's actually very real issues with that coming down the line. But that's my general view on it anyway.
Right. So they're competing economic sort of worldviews, but I think that one of the big differences is one has a very fixed and predictable and unchangeable sort of, I would say, plan, and the other is showing that it can upgrade and adapt and is making changes as
Mm-hmm.
it goes forward. So the merge, again, I think cannot be understated how significant that coordination was and to have it run out smoothly. Okay, let's two last questions here. One is, what are we going to do about fees? This has been a constant, I would say, a point of aggravation, both on the Bitcoin network. I think Ethereum's come under criticism of this. Some of the newer entrants have, sort of claimed to have lower fees and have sort of sprouted larger communities that also seem to have taken, I would say, significant beatings in the last 12 months. So a lot of people argue that the merge would lead to a future state where fees would become more affordable, making accessibility to the Ethereum protocol easier to run applications on. Because if your fees are high, it gets expensive to do any of the on-chain computations. So walk us through a little bit of what that looks like. And it's really sort of the same question I wanted to conclude on, which is, what's the next 6 to 12 months look like? What's on the roadmap, and what can we kind of expect from the Ethereum community?
Yeah, so Ethereum scaling strategy is multi-pronged, and it has been for quite a while now. And I won't get into these other networks that obviously have cheaper fees and why that's the case and all that sorts of stuff, because I could talk about that forever. I'll just focus on what Ethereum is doing to kind of fix its issues here. So as I mentioned earlier, Ethereum is trying to be this credibly neutral settlement layer, global 24/7 always online settlement layer. Now, to do that, it needs to restrict itself. It can't be everything to everyone. It can't just like keep scaling up and keep throwing more hardware at it and making it hard for people to run nodes and centralizing the network, so to speak. It can't do that if it wants to achieve that goal of becoming that credibly neutral settlement layer. So by understanding that, by realizing that, the Ethereum community has basically said, well, let's scale via layers. So let's scale via layer 2, layer 3. And there's a lot of these solutions actually alive today. And people may have heard of them: Optimism, Arbitrum, Polygon, Starkware. There's a lot of them now, right? I'm not going to list them all because there's too many now, which is pretty crazy, because a couple of years ago we didn't have any of this. And now we have a lot of them. And they're not just like existed as ideas, they're live, and there's apps on there, and they've reduced fees considerably. For example, on Optimism and Arbitrum, you can do a swap for like 10 cents, and that is actually running on Ethereum. They're not separate networks, they're layer 2s built on top of the Ethereum layer 1. Now, that cost is going to come down even further as time goes on, as these networks themselves upgrade, as Ethereum, the base layer, gets upgraded to support that. Now, the merge itself didn't actually reduce gas fees. It wasn't meant to. It wasn't meant to be a scalability upgrade, but it laid the groundwork for what's coming next. So it's basically like when you're building a new high rise, you obviously lay the foundations, which are the most important parts, because you don't want the whole building falling over once you build everything on top of it. So we built the foundation with the merge, which was proof of stake Ethereum, and a bunch of other things around that. And now, over the next 6, 12, 18, 24 months, I mean, the Ethereum roadmap is quite long, but in terms of the next big upgrades coming, we have what's called proto-dank sharding, which is basically a variation of sharding, which has been talked about for a very long time within Ethereum. Now, sharding is going to be a base layer upgrade, but it is not for users on the base layer. It's for users on layer 2. So what it does is it doesn't reduce transaction fees on the base layer Ethereum or the layer 1, it reduces them for layer 2s. So the layer 2 cost will collapse probably to under a cent per transaction, probably even less than that, right? And then users will sit at these layer 2s and do all their business there. And the layer 2 basically bundles up all those transactions and posts it to layer 1. That's how the layer 2 essentially works. It acts as a wrapper around these transactions, and it works off economies of scale, obviously, and they've got a bunch of other technical stuff that they do to lower the fees as well. But that's the Ethereum scaling, roadmap. Layer 1, base layer, keep it decentralized, keep it secure, keep it as that settlement layer, get the users on layer 2s, and let the layer 2s blossom. And I actually think that's a really cool way to scale, because what it means is that we have all these layer 2 networks that compete with each other. So they compete with each other to be better on fees, be better on speed, be better on just general user experience and apps and things like that. I think obviously not all of them are going to quote unquote win. There's going to be a pretty a normal distribution of where there'll be some really large winners and there'll be like a long tail of smaller networks. That we see that with everything in technology, but that's essentially how Ethereum is going to scale. So every single upgrade that's coming to base layer Ethereum got to do with scalability is scaling is meant for layer 2s. It's not meant for users on layer 1. And as I said, the reason we've done that is so that we can actually build Ethereum as that settlement layer, because if you start scaling Ethereum layer 1 for end users, you do what Solana has done, just as an example, because Solana takes the opposite approach here. Solana doesn't want to scale via layers; it wants to do everything at layer 1. But exactly, as a monolithic chain. But to achieve that, what they do is they throw hardware at it, right? They throw massive data centers at it. And then regular users can't actually run full nodes on their own hardware. You
And
lose
then you end up with a
decentralization.
decentralization problem, which is that it's not decentralized, and single
Exactly.
points of failure cause
Yeah,
reliability issues.
Yeah, exactly. Reliability issues and stability issues. We've seen it's very hard to keep a network like that alive because you're throwing so much at it, right? It just becomes overloaded. And essentially, the way I look at the Solana approach is the way the Web 2 has scaled, where they kept throwing hardware at it, right? There are software upgrades that have obviously help with things, but they've had to do things like Cloudflare, like DOS control, right? Because when you have a centralized server, people attack it and then it can go down, it can fall over. So that's the approach that something like a Solana has taken, but Ethereum doesn't want to take that because, as I said, if we do that at layer 1, we lose what makes Ethereum special, which is the decentralization, the security, the robustness. Because the Ethereum network technically has never been offline. Not once in its entire life has it been offline. It technically has 100% uptime. The worst thing that happened to Ethereum was in 2016 when we had what was called the Shanghai DOS attacks, where the chain actually did get DOS attacked. There was a bug and it, I think, degraded performance by about 80%. But the network still was live. So Ethereum is prioritizing for robustness, stability, and reliability rather than scalability at layer 1. And then we'll move scalability to layer 2. And then everyone can do whatever they want at layer 2. That's the beautiful thing. You can do whatever you want at layer 2. You can manage your network the way you want it. You can put whatever you want into it. You can use whatever language you want. You don't have to use Solidity. it's awesome. And I actually think that scaling approach is much better than trying to do the monolithic approach where you just keep throwing hardware at it and eventually you hit a wall. Hardware doesn't scale infinitely. I mean, Moore's law is dead. It now Moore's law went from, I think, every 2 years to every 6 years now, because we've hit that kind of wall in hardware scalability. So the only way to scale now is via software, which is what layer twos do. But layer twos also benefit from hardware scalability. And this goes into something like zero knowledge proofs, which people may have heard of, where you can actually put ASICs. So ASICs don't have to be miners. ASIC stands for application specific integrated circuit, which is basically just a piece of hardware that has a specific purpose. You can point ASICs at ZK stuff, and you can prove these zero knowledge proofs faster and faster and faster, more economically, and that allows you to scale the layer 2 even more, cheaper fees for users. So essentially, Ethereum gets the best of both worlds. It gets the hardware optimizations at layer 2, it gets the software optimizations at layer 1 and layer 2.
All right. So, in summary, thanks really to the merge and the efforts of the open source development community at Ethereum. We now are pursuing a multi-pronged approach to scaling. So, layer 1 will remain decentralized, secure, censorship resistant, and pushing a lot of the transactional load onto layer 2s for extendability. So, Anthony, thank you so much for your time and your balanced and neutral perspective on all of this. We deeply appreciate it. For those of you that want to keep up with Anthony, he's got over 250,000 followers on Twitter. He is the author, publisher, and team behind the Daily Gwei, which does everything from TV shows to much more diving deeply into some of the more technical and nuanced topics around the Ethereum community. We're lucky to have him on today. So thanks again, Anthony. We're so glad to have you with us on the blockchain.com podcast. So if you didn't know already, you can buy your first Ethereum or set up a recurring purchase. It's a great way to get a little bit of Ethereum and then start to explore all these great extendable applications that are being built on top of the Ethereum protocol via your blockchain.com wallet. So thanks again, everyone, and have a fantastic day.